Hi everyone and welcome back to my bench. Today we're gonna be working on a project to further improve my setup in the garden using this capacitive soil moisture sensor, where I want to build a battery operated sensor that will be running ESPHome on this ESP07 module and will connect to my Home Assistant setup so I can at any given time know what the humidity of the soil is, and based on that we will know to turn on the irrigation that I have set up. Now, a while ago I made a video where I explained how this sensor works, and I've used it to connect it to Arduino, so you can go out and check that video if you're interested to see the basics of the sensor, because I will not be covering that in this video, but instead I will be focusing more on getting it to work with ESPHome. And for that, the first thing that we need to do is to figure out a way how we can flash the ESPHome firmware to a board like this. So this is the ESP07 module that comes on a small PCB with onboard ceramic antenna and an antenna connector. We won't be using that one in the current setup because I think that the ceramic antenna will be enough. And the idea is that compared to a standard node MCU as I used in my projects, which looks something like that, this is a lot smaller. Just the module on the node MCU without the USB to serial and all of the other components. So the idea is that we can minify the project as much as possible and have it battery operated. So the plan is that I run this directly out of the battery voltage, and hopefully it works okay. We'll see. The goal is to have something that will run for the summer season, so about 3 to 4 months of battery life, because afterwards I will remove it from the ground and I can charge it up and get it ready until the next growing season next summer. And before we go any further into today's projects, I want to thank today's sponsor, which is PCBWay. PCBWay allows me to create all of these beautiful PCBs for my projects that you can check out in the link below. And not only that, PCBWay also provides services for 3D printing and CNC machining that can help you out with all of the projects. They already have an awesome project library that you can also check out, so you can get ideas and ready-made PCBs, including all of my own, and you can go inside their website to find inspiration and order any of these if you want. PCBWay is the one-stop shop for all your manufacturing needs, so check out the links in the video description for more details and for a welcome bonus for your first project. Now, to program the module, I'll be using a board like this. This is a USB to serial converter that can operate on 3.3 volts, and this is really important because we don't want to burn the module out without any voltage regulator on it. And from here we have connections for 3.3 volts ground, RX and takes to talk and program the module. This one is the same that I used to program some of the on-off switches. That you can check that video up here if you want. And the way I have it connected is I'm using a breadboard to just provide me with multiple connections, because on the board itself we need to connect quite a few pins in order to make it work. Let me go a bit closer on that. So this is the back side of the module, and you can see we have VCC and ground connected here at the bottom, and next to ground we have connected GPIO15 also to ground. The enable pin we have connected directly to VCC. Then we have the takes and RX connections that are switched, so takes connects to RX on the module and vice versa. And one final connection that we need to make temporarily in order to get this module into flashing mode is GPIO0, which I have it connected with this white wire that when powering on the module for programming, we need to pull that down low. So let me show you that, how it goes. Okay, so now this is just an extension lead that I have coming in from my computer. If I connect this, we'll see that it will start running and flashing the onboard LED. But in the state where it has its code running, if we go to the Arduino IDE and if we try to upload the blink sketch, I'm gonna change the timing here to 500 milliseconds just for demonstration purposes. And if I try to upload this, it will compile the sketch, but when it tries to upload it, it will stop and throw an error. So now it tries to connect to the module, tries several times, but after a while it will give up and say an error that it's not able to communicate with the module because the chip on the ESP board is not in a flashing state. So we need to change that and connect the GPIO 0 to so here's the error message, so fail uploading. And to fix this, we need to power off the module. We need to connect GPIO 0 to ground. So I'm just gonna make sure that it's not off. It's a bit sketchy, but this is a once-off project, so once-off thing. It's worthwhile, but you can get certain adapters that you can do this. Now, if we power on, we'll see that the LED is no longer flashing, so it's not running the code that we have here. And if we now try to upload, let's see what happens. It's gonna compile the sketch again. And now we should see a difference. When it says connecting, it should start uploading, and it did. So hopefully everything goes well. Yeah, we will wait for a few seconds for the code to upload, and then what we will need to do is to break the connection of GPIO 0 and reset everything. So okay, so it says done uploading. Now we need to power it off, remove the GPIO 0 connection to ground, and then power it on. And now we see that it blinks much faster than it was blinking before. Now, from here, there are a few other things that we need to do. And the first one that I want to do is to remove that red LED, that power indicator, because remember, the goal is to have this whole thing battery operated. So the less current that we can waste on LEDs, the better. So in order for me to do that, I will need to use my hot air station, try to heat up the board, and carefully remove that LED physically from the board. So let's see how that goes. Okay, so that went quite good considering just the size of the LED, which is this here. I was able to successfully remove it without any damage to the module, probably without any damage to the LED itself, but that's really not our goal here. The goal was to remove it. Now let's try connect it again and confirm that it still works. Okay, so let's connect it, and you can see that we now have the flashing blue light, but without the red LED. Hopefully that would save us a few milliamps in the final project. Now, next up is to connect the ESPHome firmware on the module, so we make sure that we can communicate through it with Home Assistant. And for that, I connected once again GPIO 0 to ground using this white wire, and I'm gonna start the module in flashing mode so we don't see the blinking blue light here. If we go to our screen here, I'm at the web.esphome.io page. So I'm gonna try and flash the board with the Home Assistant firmware. I have COM5, this is the port, and I'm gonna say prepare for first use. Let's see if the module is recognized and if it starts to install. And it looks like if it's doing that. So let's wait a minute and see how this goes. Okay, so seems that the configuration is installed. I'm gonna close this one and I need to now power it off. So it says that Wi-Fi serial is not detected, but that is because we still have GPIO port 0, so we need to turn this off, remove this wire, and now if we try to power it on, hopefully now it starts with the ESP firmware. Let's see within Home Assistant. Okay, so that does not seem to have worked immediately, but what I did is I went into ESPHome, I clicked on add new device and followed the steps here to get here and download the binary, which I then installed directly from here by using the install button. And now we seem to be having the device here, and we also got the message that it's installed. Let's add it. Okay, so finish. We have 9 devices and we have the garden soil moisture. Currently we don't really have anything inside, and I think it's best if we try to edit. Let me try to increase here this board, because it's not a 01, so it's a 07. Let's try to save and wirelessly install this, and hopefully with that we can configure and make sure that we have control over the module. Let's see how this goes. And that seems to have worked. We have the module back online. So now next up is to start adding the soil moisture sensor and investigate the deep sleep options for the module. And here is the sensor now connected with the soil moisture sensor, and I have it connected to Home Assistant, where it reads the moisture content currently in the air at about 1 second, and this is the code that does that. It's connected to pin A0, but because I'm using the ESP07 module, that does not have an internal voltage divider, so the input voltage that we need to apply is between 0 and 1 volt. And the soil moisture sensor by default will output up to 3 volts, usually around 2 point something. So I'm using a voltage divider of 220 kilo ohms resistor and 100 kilo ohms resistor that should divide the voltage to about a maximum of 1 volt. And if I now, we can see the percentage output. And if I take a glass of water to simulate moisture soil, as I dip it in, then it goes a bit over 100%. So we'll need to calibrate that a bit, because we shouldn't want to go over 100%. Now let me wipe this off, and it should be down to about 10-12 volts, and we can vary that using the calibration function, where we can set the voltage when on 100% and the voltage when on 0%, based on the output that we have from the moisture sensor. Now, as a proof of concept, this all works. Later on, I'm gonna enable this median sensor, so we're only reading about every few seconds, and I'm also gonna increase the update interval. And now my goal is to move all of this to be battery powered, because that will be a big variable in the whole project. And if that works, then we can move to deep sleep and moving everything into an enclosure. And to make the whole thing running out of batteries, I use the two 18650 cells in parallel that I have salvaged from an old laptop battery, and I've added a TP4056 board so I can later on charge and also use the built-in protection to discharge the batteries to a certain level before everything cuts off. And because the operating voltage on the ESP07 is from 3 to 3.6 volts, and the battery would output about 4 volts when fully charged, I'm using a diode in series with the circuit, so there is a small voltage drop on the diode, and that from about 4 volts on the battery that provides about 3.8 on the ESP07, which it seems to be running fine, and I have it running this on my bench for a couple of minutes. Currently it's not showing anything within the soil moisture, but if I get the sensor and hold it in my hand, then it changes the capacitance and starts showing something. Now this whole thing works. I haven't done any measurements in terms of how long this will last, but we will take a baseline reading with my multimeter. Currently I'm gonna connect it in series here so we know how much current we draw from the battery, and next up will be to add some deep sleep functionality and package the whole thing. Okay, so now the whole circuit is currently off and I have my meter set to 200 milliohms. Okay, so we are drawing about 76, 77, and I'm guessing that will drop out depending on how the ESP communicates and connects to the network after the whole boot process is complete. Let's wait a bit for that to stabilize. And I think we are already online because I can see the values changing. And yeah, that's about, I think, the best we can get. So 73 milliamps is our baseline. Let's see how we can improve that by adding some deep sleep to the code. Okay, so that was fairly easy to be done. You can see now that we are drawing just 3.6 milliamps and the whole device is in sleep mode. So if I touch the sensor, nothing changes in the dashboard, so we can see that it stays with the old value that we have, and after the timeout have passed, then the device will boot up. And for that to happen, I had to connect one of the GPIOs with the pin reset, so that is used to basically reset the ESP07 so it knows to boot up again and connect to the network. That happens in about 5 to 6 seconds from what I've seen, and we can see that over here. So let's wait a second for it to boot up. Okay, so it's starting to boot up now. I'm gonna get the sensor in my hand and we should see in just a few seconds that the value will update once it connects to the network and becomes available. So still connecting, and now it's updated to 60%. If I release it, it goes back down to 20 something. So we will need to do some adjustments on the values that we use to provide the humidity, because now it's running off a slightly higher voltage and that might be an issue. But I think we are currently okay to put it outside, and for that we're gonna need an enclosure, and once outside we can work on the final firmware to make it sure that it works as expected. We can probably go a bit lower on that, because I think that most of the current that's currently spent in sleep is by the sensor, and we can verify that if we disconnect the sensor from power. And now we go down to what it says 0 milliamps, but that's probably something that is measured in the microamps, so something like 27 close to 28 microamps, which I think would be quite good to have. But again, as I said, I'm gonna leave that for later on once we have everything inside an enclosure. Now for the mounting and in the enclosure, I can choose one of the 3 options. So these are all electrical boxes that I like to use with my projects in an absence of a 3D printer. So that would have been best if I can print an enclosure. But unfortunately, I have to result in using one of these boxes. This one is the only one that comes with a grommet, so it can isolate any moisture. But unfortunately, what I don't like about it is that it has screws on the top, so moisture can go down through the screws, because I plan to have the sensor sticking out from the bottom and being stick into the ground, and this would sit in the garden like so. This one, on the other hand, already has holes on the side with this rubber grommets, but they don't seal that very well, so I think that moisture will be able to come down, and it has a lid that goes on top, so I think I'm gonna go with this one. It doesn't have the grommet inside to isolate, but it should have enough overhand, and I'm gonna add some hot glue once everything inside and working, so hopefully I make it as watertight as possible. And I'm gonna make a slot in the bottom where I'm gonna probably epoxy the sensor in, and it's gonna stick from the bottom. Now let's put everything inside the box. Here's the final assembly moment. I have the sensor epoxied on the bottom of the case, so we can plug it in. So I need to be a bit careful because the glue is not fully cured yet, but I just want to make sure that everything works. So we have the sensor connected, and I've added male and female header pins on the battery and on the modules, so I can disconnect it if I want to. And I also, because I use the same color heat shrink, I also marked the positive and negative on the battery on the terminal, so the black goes with the black. Let's see if it's gonna work. We saw the blink there. Let's see if it's gonna appear in Home Assistant. I don't see a reason why it shouldn't, but let's just double check that it's actually there. And yeah, so currently it reads 0, and if I touch it with my hand, then it goes up. So we know that it's sending, and in a while it should go to deep sleep, and we can now package everything up inside the box and put it outside in the garden. To further prevent any shorts, I'm gonna just wrap the pack with some electrical tape together with the charging board, making sure that I leave the connector visible. Okay, so That should be good enough. And this will sit something like this. So let me figure out what's the best placement. So something like this, and we can tuck everything inside. I'm gonna add just a touch of hot glue to the batteries so I can secure them in the case so they are not floppy. Okay. Let's see how that goes. We can add the lid. I'm not gonna seal this just now because I want to have this running on my bench for at least a few days before I put it outside to make sure that it runs okay. The final touch, and we can now call it complete. And with that, I hope that you liked this video. I definitely had a lot of fun building this thing, and sure it's gonna be helpful in the garden. If you want to have further updates on the sensor, make sure to subscribe to the channel, share this video if you find it interesting, and I would see you all in the next one. Cheers!